Good morning, everyone, and welcome to another Enriching China webinar. My name is Mariana Marques, and I'm here on behalf of SPI, who is the coordinator of the Enriching China project. So today, in our webinar, we will talk about AI technologies that can help fighting COVID-19, and we will present two case studies from China. Our webinar today is organized in cooperation with two Chinese organizations, the Changfeng Information Technology Industry Alliance and ZHONG number 1. These two organizations are represented here today by two representatives. From Changfeng Alliance, we have Ms. Zhang, and from ZHONG number 1, we have Ms. Daisy Liu. So now I will pass on the word to them so that they can briefly present you their organizations. So please, Ms. Zhang, if you can go ahead.
Okay. Thank you, Mariana.
You're welcome.
Hello, everyone. Yes. Yeah, hello, everyone. Greetings here from Beijing. It's in the afternoon here, 4 p.m. in Beijing. And it's very exciting for us to join this webinar hosted by ENRICH China. And we have done a lot of work together to make this happen. And at this time, I just want to briefly introduce Changfeng Alliance. And if you have more interest in contacting us, there's 2 QR codes right in the bottom of this page for everybody to scan and then know more about us. So Changfeng Alliance actually was established back in 2005 and by a group of software, information service enterprises, research institutions, and third-party institutions that focus on independent intellectual property rights with the support of state and the local governments. So as of today, we have a group of nearly 300 member companies covering software, system integration, AI, 5G, IoT, cloud computing, big data, medtech, and internet companies, etc. So for us, our goal is to help our member companies to connect with overseas market, as well as helping international companies along together with our partners, for example, in ENRICH China, to get into the market and to find the business opportunities and connect for projects. So that's it for me. And this next page is our professional services, just to briefly show you what we do here: consultancy, industry integration, internationalization, as well as marketing and events. I think that's it for me, and thank you. I look forward to this event and welcome this opportunity to chat and learn with each other. Thank you.
Thank you so much, Ms. Zhang, for your words. So now I will ask Ms. Yu to present ZHONG number 1, the other organization that are cooperating with us for today's event. Ms. Liu. Ms. Liu, can you hear me?
Hello.
Hello. Please go ahead.
Hello. Thank you. Thank you very much. Actually, it's a pleasure that we invite some great enterprises to participate this great event forum to discuss the situation in China. And firstly, I would like to introduce a little bit about our the high-tech industrial park, because we have actually a lot of this kind of AI companies and this kind of companies. So first of all, a little bit of introduction. ZHONG number 1 is the origin of the science and technology innovation, and it's the source and main position independent innovation in the new era. And it's the landmark buildings for the Changfeng Science City. Besides, we have almost 50 companies in this area. And so maybe in the next time, maybe we can have more technology companies that can discuss some high tech with the European countries and companies together. So thank you.
Thank you so much, and we look forward also to that opportunity.
Thank you.
Thank you so much. So now, before we start with our two presentations of today, I will just introduce you the agenda very briefly. Our first speaker is Mr. Jiadi Yao from Sigma Square Tech. Is going to talk us about two case studies of AI technology application in China during this COVID-19 outbreak. So Mr. Jiadi Yao is the founder and CTO of Sigma Square Tech in Beijing. He's a technical entrepreneur with 10 years of experience in network systems and platform architecture. Regarding his company, Sigma Square Tech, this is a high-tech Chinese foreign joint venture that integrates research, development, and production of vision inspection systems and cloud vision services. They work in the Chinese market, but they are also working in the Southeast Asian market and in Europe. For our second presentation about IPv6, the single biggest technology disruption of the 21st millennium, as it is presented here, we have Mr. Hardy F. Schloer, who is the founder and CTO of Prisma Analytics. Mr. Schloer is a data scientist with many years of experience in system design, development, and implementation. He's the founder and owner of the Schloer Consulting Group, and he also founded Ravenpack International, which is a leading data and analytics company. Regarding Prisma Analytics, the company in which he will present us today, they work is aimed at combining big data analysis and artificial intelligence to help decision makers leveraging data into actionable knowledge. So these are the two presentations that we will have today, and at the end we will have the questions and answers section. I will now give you a little information about this part. I will please ask you to check your GoToWebinar panel control. You will find a section there called questions. You can write there all your questions during the webinar, during the presentations, and then at the end I will read them and ask them on to our speakers. So please feel free to write there any questions, and we will address them at the end. So now we will start with our first presentation with Mr. Jiadi Yao. Let me just put the slides on. You can see them. And Mr. Yao, yes,
hello.
You're already there. You can go ahead.
Yes. Okay. Hello. Hi. Good morning. Good afternoon, depending on where you are. Welcome to this webinar. My name is Jiadi. I'm one of the co-founders and CTO of Sigma Squares. I'm here to give you a brief talk about the application of AI in the manufacturing in the recent COVID-19 outbreak and how AI have helped to keep the factories running in light of the lockdown and the social distance orders and keep the vital products coming. Next slide, please. So my talk will split into three parts. Background, to talk about who we are, what we do, and how we could possibly help, possibly contribute in this global crisis. And then two case studies. So first one will be talk about AI-enabled production line that makes key items in fighting the COVID-19. And case study two, I'll talk about our assistance in helping the face mask production. Next slide, please. Next slide. Yeah, that's the one. I'll start with what we do. So in a sentence, we provide machine vision solutions to create intelligence for manufacturing processes with an aim of improving quality, increasing efficiency, reducing waste, and lowering cost. So our customer can therefore better visualize the future with this smart manufacturing approach. In detail, how we do it, we capture images with carefully designed optics and then send them to the cloud computing facility to be analyzed. On the cloud, the complex artificial intelligence algorithm can be applied to provide useful information for manufacturing processes rather than just a fail or pass result, which is how most of our competitors do it currently. The information and images are all in one place, and this is very important so that they can be further used in process improvements. Next slide, please. So Sigma Squares was founded in March 2018. So I'm one of the co-founders and have a PhD in web science with background in computer networks, industrial networks, cloud computing, etc. The other two, so Cai Zhonglun has a PhD in automation and he has expertise in machine vision and AI algorithm in industrial applications. The third one, Xunan, knows how to run the company, have done quite a few successful startups. The last one, Changfeng, who actually knows the market in China and knows how to sell, basically. We have attracted 3 rounds of funding so far, exceeded 24 million Chinese yuan in investment. We also own the British brand C² Visions. We have awarded Zhongguancun High Tech Enterprise and National High Tech Enterprise in 2009 and various other awards. We currently have 4 research centers. So in Beijing is our headquarters, and then the Shenzhen focusing on the 3C market, you know, the mobile phone, tablet, and then the Chengdu focusing on the pharmaceutical and the medical devices manufacturing, and Southampton. We currently have 40 plus talented individuals and more than 60 plus customers so far across China, UK, and the US, and 80 plus currently active completed projects. Next slide, please. So old-fashioned manufacturing is outdated and not efficient. With an increasing labor cost, this style will come to an end without changing, especially in the current COVID-19 lockdown. They simply have no labor to do manufacturing. So here's our Sigma Squares value proposition. It is smarter. We use latest computer vision and machine learning and AI technology to assist manufacturing, reducing repeated and manual labor, building a more controllable, predictable, and continuous improving factory. It is better connected. Multiple stations, multiple production lines share the centralized cloud server that creates a network that reflects the product's health. Eventually, the production is more efficient. The data collected in the centralized cloud server is analyzed in real time by AI algorithms, allowing continuous improvements to the manufacturing process. As a result, increasing efficiency and lowering overall cost. So I want to emphasize that we never focus on the technology itself. The technologies are tools. Machine vision, AI, industrial network are tools that we utilize to solve manufacturing problems. The problem is the focus, not the tools. Next slide, please. Just very briefly to talk about our technology architecture. There are basically 3 parts, left, central, and the right. So the left part is a production line where products are made, inspected, and packaged. Our system in this part consists of a vision hub, the blue box in the middle, which talks to the camera, talks to the production line, and displays the real-time camera images. When this vision hub takes an image of the product to be inspected, it sends to this enterprise cloud vision server in the center. On the cloud, all the magic happens. It looks at the image, looks at who sent the image and various other data, decide what algorithm to use to process the image to get the intended results. For example, if we are inspecting contact lens, depending on which stage the lens is in, it may invoke, like for example, high gross defect, gross defect detection, or in-mode detection, or wet for inspection algorithms. Different algorithm and different stages look for different defects. Some actually does measurements. The output is immediately returned to the vision hub to tell the PLC, which controls the production line, whether the current product it is looking at is defect or not. So an injection system can take the faulty product away and recycled. The algorithm output together with the input image are also stored in the server database for future analysis and continuous improvement. On the right-hand side is a series of software that utilize the data stored in the vision server. For example, for management team, they would like to know the production data like productivity, yield. The software generates a query and pulls the relevant data out from the vision server to show it to the management user. Similarly, for quality assurance team, where they spotted a faulty product slipping through the inspection or customer complaints against a certain item, they can very quickly pull out the said product's inspection record in all of the workstations that the product has been to, images, results of the algorithm output while it was produced to investigate further. For vision engineers and controls, they can get operational data, allow them to further improve the algorithm. Next slide, please. Okay, so move on to our first case study, deliver a fully automated and AI-enabled production line. Next slide. So our customer, it's just some background on what we've been doing. So our customer is a reputable lab equipment manufacturer. They founded in 2002 and a manufacturer of more than 100 products across 10 product category. Headquartered in Beijing with subsidiaries in US, EU, and India. This is their main manufacturer plant in outskirts of Beijing. So one of the few manufacturers still standing in this capital area, actually. Others have long moved south due to the cost and labor availability, etc. So in a way, they are pioneers in terms of adopting advanced manufacturing process and recently AI-based fully autonomous manufacturing methods. Next slide, please. So just some background on the products they are produced. That we produced a fully automatic assembly line for. This is called transfer pipette, pipette or chemical transfer droplet gun, depending on the usage. It basically allows transfer a very fine controlled amount of liquid, often in the range of like 10 microliters of liquid. It is one of the key lab equipment in the COVID-19 lab testing, as testing is one of the key activities of controlling the virus and advocated by WHO. Countries around the world has been trying to ramp up their testing capacity. This equipment is under high demand. Next slide, please. So the challenge, naturally, when the demand rises, manufacturers should be the one smiling and happily ramp up their production to meet the demand. However, not in this case. Before COVID-19 in manufacturing, you can use people, I mean a lot of people, to quickly scale up your manufacturing capacity in China. However, it is right in the middle of the outbreak. It poses two issues. So one, crowded environment in the factory potentially is a health risk to transmit COVID-19. Secondly, factories cannot recruit enough people due to the lockdown situation during this pandemic. So the second challenge, quality check requires people to rotate the dial to each and individual digits, which is error prone and low efficiency. And similarly, they cannot recruit enough testing technician to conduct testing. The third challenge, this is the issue they always wanted to resolve to bring in their manufacturing cost down. Raw material waste. When issues are discovered at the final stage, for example, like bad or wrongly printed digit, misaligned digit, as it is how their existing manufacturing mode is, it is very high cost to reuse the good part in a bad product. For example, trying to open a glued together product to salvage a good part. This process is troublesome, and the good part is easily damaged during this process, causing the material waste. Next slide, please. The solution. So the solution we have produced to D-Lab is a fully autonomous assembly line. Here are some schematics and 3D visualizations of the proposed automated assembly line. This is the hardware part, the mechanical part that assembles the product. It's sort of the easy part because it has existed a long time, and the process is quite mature in producing these assembly lines. Next slide, please. Here is a finished product. So this is just one line capable of replacing at least 5 people per shift. They are planning to place more subsequent orders once this equipment is fully in service. Next slide. So some of you may think, this assembly line thing has existed for years. How is this to do with AI? I hear you. The magic is in the software. There are 2 aspects that we have utilized AI in our system. So firstly, AI-based machine vision in quality inspection stage. So machine vision, in other words, is using camera plus vision algorithm instead of human eyes plus brain to tell the bad part from the good parts. Vision algorithms comes in 2 flavors. So broadly speaking, conventional geometry-based algorithm and machine learning. In other words, AI-based algorithms. AI is about learn from data and its ability to make sense of this high-dimensional data. The key difference is that conventional algorithm requires experienced vision developers to work closely with the manufacturer to define in a computer language what does a good part look like that should pass versus a bad product that should fail. While AI vision algorithm requires a manufacturer to train the AI algorithm by providing sample images of the good product and sample images of the bad product. So in other words, for manufacturers to work with the AI algorithm, they just need to collect samples of the good product and bad product, showing the specifics of the defects that needs to be checked. It is often not that clear cut, at a deeper level that which approach is better. So but in this instance, the AI approach greatly simplifies algorithm development, so we used it. The second aspect where we used AI in this early warning is in the early warning and the predictive maintenance on the key parts of the system. We have installed sensors, a lot of sensors in key parts of our system. For example, pressure sensors in the pick and place head, temperature sensors in various places, speed sensors in the belt, etc. So the maintenance AI module collects the real-time data from these sensors and constructs a normal view, if you like, a normal state of the working production line. So when, for example, the conveyor belt is slowing down due to, I don't know, things got dropped into it, stuck into it, a warning is flagged to notify the engineers to investigate the anomaly. When the temperature of a certain area raised, the AI algorithm would also spot the anomaly, but also considering the day-night temperature variance, summer-winter variance, etc., before giving out a definitive warning to the engineers. Next slide, please. So Maria, if possible, if you can play the video here. So yeah, so this here's some videos of our running system. This one is a dial 1 installation station where the dial part is picked, checked, and then installed. Yeah, next slide, please. I think it's already played once. And this is the vision inspection station. So pick hand takes the assembly part, assembled dial, and placed in front of the camera. So the camera is a circular device on the left bottom. The infrared light is on the left and right, those little white square panels. And then once it's given signal, it drops into the tube, depending on whether it's a good part or not. Next slide, please. So the result, it increased the D-Lab's output of this highly demanded product and reduced 5 staff per shift, a reduction of 80% of required staff, increased overall productivity by 44% compared to the equivalent manual process, and enabled defect part recovery because of the early inspection process. Next slide, please. Yeah, so that was the first case study. And then the second case study. So we partnered with a mask manufacturer to fulfill the emergency production requests. Next slide, please. So face mask is undoubtedly the item that is in most demand since the outbreak in China. Most outlets basically sold out the mask at the beginning of the outbreak and put a lot of pressures onto the mask manufacturers. Next slide. So ZHONG Biological Engineering stood up to fulfill the emergency face mask production requests by Changfeng District Government and the Beijing Medical Products Administration in short notice. Sigma Squares. So we, with its automation expertise, partnered up with ZHONG to assist with automated manufacturing process. Next slide, please. The solution is a PLC-based program control, a fully automated face mask assembly line, and it is up and running in a few days. Automatic fabric cutting and strap glue. And does not require manual intervention in operation. Next slide, please. So the result is enable ZHONG to produce face masks to fulfill orders, and the production rate is around 45 to 55 pieces per minute. So the assembly line does not actually has no advanced AI in it, nor does it need to. The point I want to make is that as a responsible company, we're trying to use our technology, our skills, everything that we could to make contribution to help this global crisis. Yeah, I think that's the end of that's everything that I would like to cover. How is the timing? I hope I'm still within the time. Maria, back to you.
Yes, yes. Thank you so much for your presentation, Mr. Yao. You were perfectly within time, and you shared very interesting knowledge with us. So now I will pass on the word to our next speaker, Mr. Schloer.
Thank you very much.
Hardy,
I think I'm
I
sharing my screen, right?
I will pass on the screen to you now. You should be able to share it. Yes, yes, we're already
Perfect.
seeing. Perfect, thank you.
So, okay, now it works. I hope everybody can see my screen.
Yes,
Obviously,
very well.
the correct title should have been IPv6, the single greatest technology disruption of the 21st century, not the 21st millennium. Obviously, we are not quite that advanced. And I want to show today how a simple adjustment in the IP number format unlocked literally the superpower of smart data and quantitative AI, and it, I believe, paved the way into a complete AI-based future. I'm trying to, okay, here we go. So since the information explosion was observed in about 1941 or so, the rate of which we created data has just absolutely been explosive. 80 years later, we find ourselves drowning in data that we don't manage well. And the extraction of causality from data is obviously the single most important and most rewarding task in the pursuit of intelligence. So understanding causality builds the logic prime feature of all knowledge, and that is known through philosophy and known throughout all the processes that we do. So consider that the first system to achieve the ability to capture, organize, process all of the world's available data will become the world's knowledge standard. So how do we achieve that? Until Prisma built the quantum relations machine, really no solution to unite all of the world's raw data that might unlock this gateway to exponential human and machine knowledge acceleration had ever been constructed, nor had it even been attempted. The goal simply sounds too big. So the Prisma Analytics quantum relation machine is really the world's first serious attempt to capture and to unite all of the world's available data and optimize it in a fully automated artificial intelligence based machine environment, and all that under the regime of IPv6 as inter-data association and communication technology. And guess what? It's working. So imagine, just imagine, one could give every single thing in the world, every place, person, object, group, and group of objects, and every concept and context, however abstract, in every minute of time, past and future, and every observable property of behavior, and anything within a unique number to identify it, recall such thing forever. And then imagine you could let all these objects associate with each other, preserving the instance and time when they are observed and associated with other objects and in what context they appeared. And further imagine, you could use all of that numbering and timestamping and instancing and contexting to recreate the entire world inside a machine, exactly in the way it was observed by any observer, human or machine. And that means even contradictory observations. And finally, imagine you could update and disambiguate every observation done by any observer and create in this way the ultimate sandbox of the universe, where all observed data of this world unsupervised self-organizes through association and communication connections. Just imagine that this all would be made possible to create the ultimate living ecology of the real world inside a machine. Imagine what you could do with that. 20 years ago, there was a magazine, The Net Investor in Germany, and they looked for the 25 most promising technologies for the future. And I was one of them that they picked. And of course, the text is in German, but I take the first message that was my quote: "We atomize the world and give every atom a serial number." Of course, back then we struggled. How do we do that? The question to ask is, how might IPv6 play a role in that envision of the future that I had back then? Let's look at the power of IPv6. That's the number of individual IPv6 addresses. That's an enormous number. That's the number of grains of sand on the earth. Quite less. Here you see it, the entire IPv6 space. And when you look at other things to compare, you understand that IPv6 is envisioned to literally address every identifiable thing on this planet, and for a very, very, very long time. It is exactly the type of technology that was needed and the methodology that was needed in order to unlock the future. So when you, for example, look at the sand of the beaches of the Normandy and what they contain in knowledge, every soldier that died, every bullet that was fired, every command that was ordered, every fortress that was destroyed, every serial number of every gun that was fired. With all knowledge of the event, you could recreate the entire landing of the Normandy in 1944. Imagine recreating the landing of the Normandy in a digital universe. We would need the ability to associate the elements, the natural elements of knowledge in the landing of Normandy with an event, with an action, a place, and a time, a concept of the idea to liberate Europe from fascism, a group of soldiers or their platoon, a person, living or dead, a geography, a location in space, a time of occurrence, physical objects, technology such as the radios used to coordinate the attack, and finally, a causation that connects the event with every moment based on every victory and every defeat. So the entire battle of the Normandy could be completely recreated in such an associative environment. Let's look at how the human brain does that. Human brain has an order of about 100 billion neurons, which seems very few compared with the numbers we just looked at. Information gathered to the 5 senses stored in these neuron receptors that the brain has, because all the brain is neurons and neuron receptors. And it operates with receptors through neurons to create associations. Often mistake associations with causations, by the way. Look, a baby, when it is newborn, it associates. First, when it's hungry, it associates hunger with mom and the breast that gives milk. And it begins to associate things, and later toys, and its pets, and then maybe the deeper voice next to the mother, which turns out later to be the father. And so it begins bit by bit to build a universe of understanding simply by identifying these prime features of location, of objects, of time, of so on, and associate them. Later, when it can walk, it's hungry, it's a sensation. A smell, it's a sensation. It's a geography, it's the kitchen. There's an object, that's the sensation. It touches and burns, and that's the association. So now it knows food is connected to a geography, connected to an object, the hot stove, connected to, I want what's on top of the fire, but I can't touch the fire because I burn. That's how we learn. That's how these little tiny things that we are putting in our brain later connect to bigger and bigger and bigger networks of information. Now, if you take exactly that idea and we take exactly the power of IPv6 and exactly the identification of the prime elements of knowledge and then just knit that all together, we got it done. The amount of all possible information to be consumed obviously is staggering, absolutely staggering. So a smart person can compare three things in parallel. Einstein's was said to can do four, but we need to do billions, billions. Look, no human can make sense out of the qualities and quantities of every association between every object in our world. It is simply too much. There is simply too many things that all need to be looked at in parallel and at the same moment. You must realize that the heavy lifting needed to make a real breakthrough in artificial intelligence could have never come from creating a smart intelligent program, with the only exception of very targeted and limited sets of data, as we've seen in the previous presentation just now. Here we have a closed, what we call a closed loop problem, and we can target that beautifully through the tools that we were just presented in that presentation. However, on a global scale, to create this global total data ecology, we could have come only to the uncompromising general conversion of raw unstructured data into an intelligent self-organizing data ecology, and that all through the power of IPv6. So you have on the left the traditional setup, data and application, and on the right we build all of the intelligence already into the data. And so let me maybe introduce you now briefly to one application. There are many that we have built already, but this is one which we call QSearch. And it was only possible by incorporating the power of IPv6. And here we will show you this. This, for example, is a knowledge object. And this knowledge object has been created by looking at Dr. Fauci and COVID on a particular day, only one particular day, the 2nd of May. And we actually can create here a beautiful object that all fits together, people and concepts and technologies and places and geography and so on all together. And these little things here, these yellow ones that are going in all kinds of directions, these are the causations between each and every one of these objects. Then we can click on the causation and boom, here we can immediately find the elements that were important, or we can investigate something more directly, and we can create it an object of Mr. Fauci on the day that he had with respect to COVID on all kinds of different things. Here, for example, a meeting and so on and so forth, and we can click on the actual causations, and we then can look up what the causality between these two things are. See, in order to find that, out of all the data that existed in that day, which is upward of about 500 million documents that were published that particular day, would take a team of about 200 researchers easily a month. No question. It takes our tool seconds to do that. Here's another example. Okay, this is New York in COVID, also just on the same day. Okay, and here we can look at this knowledge object, and we can go right into it, and we can manipulate it 3D, and we can really dive into the ecology of the information on that one day. And we can identify each and every connection and each and every causality with each and every person and technology and time and place and group and so on that was involved with respect to that one knowledge object, which really means you are now able to define any kind of space of information that you need, and you be able to get right into it. And not only that, because we are using actually information of thermodynamics, and we're using quantum gravity concepts, we are now can put that into a gravitational field, and we can even see the little outlier galaxies here that are playing a role into the knowledge object on that particular day. So this gives us a true physical reenactment of how everything connected and how everything was that moment. And because the AI-based future must be one where we are including all data from all areas and where we have no borders between different things. How is manufacturing and climate change and medicine and urban development and all of these things, how do they connect in this big ecology of our world? This is the way it can be done, and it can only be done with something as powerful as IPv6. And if I'm under my time, then I'm glad, so that we have more time for questions, and I yield back to the operator.
Thank you so much, Hardy, for your presentation. Very, very interesting information that you shared here with us today. Let me just put our presentation back on to us. So now we will start the questions and answers session. I will ask our speakers. I know that Mr. Hardy is not able, unfortunately, to connect his camera, but I will ask our other speakers if you can turn on your cameras now for the questions and answers session. I will also ask our attendants if you have any questions for Mr. Yao or for Mr. Schloer. Please write them on now on your questions box in your control panel, so I can read them onto them. So for Mr. Yao, we have here a question. It's regarding the first case study, the assembly line for the D-Lab. We are asking for how long did it take to put together the assembly line? I'm sorry, Mr. Yao, we're not hearing you. Let me just check.
Oh, hi. Okay.
Now we're hearing. Thank you.
I muted my microphone. That's fine. So I think the project started sort of in the beginning of the year. when sort of things get slowing down, and we did actually had some sort of supply chain issue in terms of putting things together. Obviously, this it was sort of a Chinese New Year, as well as the this outbreak. It took about like 3-4 months from the beginning to at the moment this whole production line is actually in their factory and sort of doing the final factory accepting tests and so on. Yeah.
Okay, so now thank you for your answer. And now a question for Hardy from Hamed Koskun. How can we know that the assumptions we make to create the model is correct? When building the model, we might put in errors in the model which impacts the data quality. How do we prevent this?
Very easy. First of all, we have to quit the idea that any one of us is correct, ever, on anything. We have to have a general model in which the data is self-telling. And guess what? Sources, as they are preserving in our model, reveal themselves over time. If a source, for example, continuously leads to conclusions that are wrong, then the source begins to disqualify itself and resides into the background and is diminished in its believability. But let the data tell about data, not humans. What we have done on our model is we have cut off completely any human intervention to produce any qualitative or quantitative statement. The machine completely and on a complete generalized system discovers data through its parsers, and it doesn't have a special parser for this particular idea to favor another idea. It's not like this. Our system has absolutely no preferences, and it treats everything exactly the same, but it preserves history, it preserves outcome, and because it preserves events. And so therefore, it cuts off the human individual bias to steer the outcome of the system. The system finds its own outcome.
Okay, thank you, Hardy. We have another question from Mr. Latif Farid, who is known to us. He's asking, how is IPv6 embedded in the Q search?
Everything gets an IPv6 number. Now remember that, for example, if we are identifying a concept, let's say the concept of love, then we give it an IPv6 number the first time we learn about love. And every time something loves something, we use the same IPv6 number. Now, over time, the system learns that some love their wife and others love ice cream. And so it's a different type of love that we are finding. And so we disambiguate, and now there are two loves, and they have two IPv6 numbers. But whenever one applies, then we use exactly the same IPv6 number. A person, Mr. Trump or whoever, Mr. Fauci or whoever it may be, when he appears, he is always under the same IPv6 number. And this gives us the beautiful opportunity to have horizontal knowledge, which is event knowledge. And we have vertical knowledge, which is tell me everything about one person. Tell me everything about 1 minute of the universe. Tell me everything about 1 square mile of real estate on this planet from the beginning of time until now. So that is how we use IPv6. I hope I answered the question.
Thank you, Hardy. Still on the first question, the same attendee, Hamed Koskun, is trying to differentiate between the learnings that we can get from humans or from machines. He mentions this. I will read. Not every baby learns the same way. Smart babies learn faster, and some have different preferences. So the impact that impacts learning as well. With machines, we do not have these circumstances that makes the difference between people. And then he asks, how do we cope with this?
Well, simply by putting into the center of everything causality. How do we know about causality? We know about it only by either looking at a film and disambiguating or parsing each and every frame of the film and its influences, or we're reading a document, and out of a document we linguistically extract causality, cause and effect. One thing happened, it caused another thing to happen. Once we are preserving causality, that is the prime feature of knowledge. That is what made anything change. Change is time, and therefore it's event. And from events we learn, and we can store that. And we can, for example, have 10,000 events of the exact same type, and we then can see that some events turn out this way, some events turn out another way. And then we can go and retrace into their context and the context of their context and that context and their members and how they behave. So in one event, we have certain types of members that tends to behave under certain conditions in a certain way. And then another event, we have other members that behave differently, all of which is captured through causality. And once we do that and we trace that and preserve it in the system, then the system becomes also highly predictable under who are the members that are participating.
Okay, yes. Thank you, Hardy. I think that must have answered the question. Now I have a question from me. In the platform that you presented, the Q search, you showed the example of some information that has been collected about COVID-19. That platform is freely accessible, or did you create it for a client? The platform you showed us online. Hardy?
Oh, you asked me this question. I'm sorry. I thought it was directed to the other gentleman. I'm terribly sorry. I was distracted for 1 second. Can you please repeat the question real quick?
Yes. I was asking about the Q search platform that you showed us online.
Yes.
You even gave the example of the information about COVID-19 that had been collected, and namely centered in New York. That platform, the information created by that platform, is it accessible to everyone, or was it created for a client?
No. It's for everyone. In fact, what we are doing even is we are building APIs to our system currently. I mean, we are collecting hundreds of billions of documents that we are parsing constantly every single day. Any kind of data, pictures, movies, tables, balance sheets. I mean, anything you can imagine, we parsing into our system, and we are offering open APIs, so where others can build applications to view and and in fact they can even a license from us a platform where they can put their own proprietary data in and view it through the same tools that we are showing open source data. And so if somebody wants to use, for example, a Q search, we offer that currently for professional environments, because it's obviously extraordinarily resource intensive and needs a lot of calculus in the background. But we hope that in the not too distant future, we also can do it for every person to learn about things and to discover things.
Okay.
And there are many other applications, by the way, of that kind. I just showed one, but there were many others I could have shown as well that have similar powerful ways of showing the information.
Okay, thank you, Hardy. That was very enlightening. At least as I made a question, I'm glad to know that this is being shared and used widely. Now we have a question here regarding the presentations of the speakers. I assume that you can gladly share your I can share the presentation with any attendee that would like to receive it.
Yeah, at the end, I will upload the final presentation, and you can distribute this one as a PDF file.
Exactly. And also with Mr. Yao, we can also share your presentation with the audience.
Yeah, no problem. That's fine.
Yes, thank you. So if everyone would like to receive it, you can get in touch with us, and we'll share the presentations and put you in contact eventually with our speakers if you would like to receive more direct information. We have no questions for the moment, so I will end the session for today. You have our contacts here appearing on your screen. So as I mentioned, if you want to get in contact with us ENRICH China or with any of the organizations that were involved here today in our webinar, feel free to contact us. But before we finish, I would like to thank our co-organizers, Changfeng Alliance and ZHONG 121 from China, as well as our speaker, Mr. Jiadi Yao from Sigma Square Stack, and to Mr. Hardy Schloer from Prisma Analytics, who also was here with us as our second speaker. So thank you once again, everyone, for attending, to all our speakers and co-organizers, and we'll see each other in a next webinar session. Thank you, everyone, and have a good day.
Thank you.
Thank you. Bye-bye.
Thank you.